Okay, thank you, Jenny, and thank you everybody for joining. Good morning and good afternoon for some of you. So what I'll try to do in 20 minutes or so, I'll try to provide you a relatively brief update on our US AMOC Science Team activities. And as shown on this cover slide, US AMOC Science Team is a US interagency program supported by 4 agencies, and they are given here: NASA, NOAA, NSF, and GOE. What I'll try to do is, since some of you guys are may not be necessarily fully familiar with the science team, I'll try to provide a brief background on the science team objectives, its organization, and a very, very brief history of it. I'll show you a few examples of ongoing projects and some recent results, and I'll conclude with some current and planned science team activities. And I would like to just upfront note 2 things, and one of them is going to be a homework for the US CLIVAR panels and the steering committee, essentially. We have, even though we are labeled as US AMOC Science Team, we have really strong collaborations and partnerships with the international community. In particular, we closely collaborate and coordinate with the UK RAPID program. And I want to also mention that the US AMOC program, as decided a couple of years ago, will be ending as a program, as a unified program, that is called the sunsetting. So it will be sunsetting at the end of calendar year 2020. So our objectives, this is, as I'll show you, we are almost more than 10 years old program now. Somebody's making sounds actually, but anyway, the science objectives of the program include implementation and evaluation of the AMOC observing system, assessment of AMOC state variability and change, assessment of AMOC variability mechanisms and predictability, and finally, the assessment of the role of AMOC in global climate and ecosystems. I did not mention actually what AMOC is. I'm assuming everybody knows that. It's the Atlantic Meridional Overturning Circulation. As of, this number needs to be updated probably a little bit, but to our best of our knowledge, we have about 80 funded projects supported by the 4 agencies that I mentioned earlier. And the project count includes some of the projects that are in their no-cost extension period. So this is our organization. It is essentially a science team. So if you look at the sort of the gray, sort of the blue, yellow, sorry, greenish area, it is the science team, the broader thing, and it includes all the PIs, co-PIs, postdocs, and students performing AMOC relevant research designated by the funding agencies. Reflecting our 4 objectives here, we have essentially we have 4 task teams. I can't remember exactly when they were formed, but going back to 2010s, and they directly match, these 4 teams directly match our objectives. So task team 1 is observing system implementation and evaluation. Task team 2 is the AMOC state variability and change. Task team 3 focuses on mechanisms and predictability. And finally, task team 4 focuses on climate sensitivity to AMOC, including ecosystem impact. As of last year, we actually formed a 5th task team that's bringing the paleo climate community from the AMOC side. It's a brand new task team, and they have been quite active over the last year or so. Current leadership is given here in red letters here. They are the task team chairs and vice chairs. Then, together with them, myself actually forms the executive committee. I'm the chair, as indicated earlier. And so that this is the structure of the US AMOC program. The executive committee, as I said, consisting of the co-chairs or the chairs and vice chairs and myself, we are responsible with identifying research needs to achieve the program objectives. We try to encourage and develop research activities to address these needs. We try to coordinate ongoing US and whenever possible, as I said earlier, international research activities to address the program objectives. We are also responsible with summarizing the state of the science and program progress and developing input to AMOC program reports as necessary. So an example, a major example of the last two bullet items is essentially our annual, well, they are no longer annual, our progress reports. They were initially annual, but with the change going to an 18-month or so period for our meetings, we also sort of synchronize these reports. So they are more like, they come out like every 18 months or so. And our next report will be coinciding with our sunsetting activities that will be published in 2020. So our last report was issued in May 2018. So just one slide summary of our program history. As I indicated, our program, US AMOC Science Team, was formed in 2008. Since then, pretty much every year, more or less, we are having annual meetings. Initially, they started as just the US program, but then starting in 2011, we started to have joint international meetings with the UK RAPID program. We call them now international, just to make sure that they are broad. The program was reviewed in 2012 and 13. And one thing that I wanted to highlight here is that in May 6, 2016, we had a workshop related to paleoclimate related activities. And as an outcome of that workshop, there was a recommendation from the community, and this was also discussed by the executive committee and the program managers. We ended up forming the Task Team 5 on paleoclimate connections. Our last meeting was an international one in 2018 in Miami, and I'll come back to that with one slide summary of that meeting. So just a few highlights. I mean, you can imagine we have over 80 projects working on AMOC related stuff, and there are many sub-projects, and I cannot really touch on every single one of them. I just try to essentially summarize some of the major sort of emerging science questions. Perhaps they're a bit biased towards what I do personally. So I have nothing to do with the observations. I don't take observations. So this is a summary of the observational trans-basin essentially programs. And we are actually quite happy. When the program started, we had pretty much very minimal trans-basin observational data sets. And you can see that we have the Osnap data sets, we have the NOAC program, that's the North Atlantic, I think, circulation, Rapid Array, Move Array, TSAA, that's the Tropical South Atlantic area, I believe, and then the SAMBA. These are really great observational programs, and we need to make sure that they continue into the future. And the start dates are given here, and they are quite a few of them are relatively new. I wanted to show you one emerging science question, and I wanted to, before I get to that, I just wanted to give you a very brief summary of, in my view, a common low-frequency variability mechanism in the North Atlantic is. The reason I'm doing this thing, I just wanted to put the science in the context of this variability mechanism. So, assuming, starting with a persistent positive NAO phase, and these are from plots from some model simulations, after a few years, not quite a few years delay, but after a relatively short delay, the models tend to show increased density and deeper mixed layers in the Labrador Sea region. That in turn, after some 2 to 3 years or slightly longer delay, leads to a larger overturning circulation, a positive anomaly. And then that in turn results in increased northward heat transport and particularly increased heat convergence in the northern high latitudes in the Atlantic. And that can lead to so-called Atlantic multi-decadal variability pattern. This is the sea surface temperature. And particularly, it is we think that it is responsible with the creation of the subpolar lobe of the AMV. Note that I am essentially distinguishing it from the tropical lobe, and that in turn can lead to negative NAO patterns. In the past, last year's presentation, I talked about AMD. That was an emerging sort of, there was quite a few emerging science questions. This year, I would like to focus on the role of the Labrador Sea. Here, I'm stressing that the many models actually show a strong role for Labrador Sea deep convection, preceding an AMOC strengthening. We have done some recent studies essentially questioning that, and I'll show you one numerical and one observational study. This is essentially a study led by Fei-Wei Li from Duke, and what is done here is essentially in this red box region here, we have looked at 4 different models: NASA GIS, GFDL MOM, NCAR, and GFDL quarter-degree MOM version, and looked at their overturning circulation within at the Osnap west line, as well as the 26.5 degrees north line, and we looked at essentially the Labrador Sea water volume in these models using a potential vorticity criteria. So these are our results are shown here. These are hindcast ocean simulations, of course, with our best estimates of the available observations. So the top panel is showing the Labrador Sea volume as a function of year, and the observational estimate is shown here in purple. So one thing that we see, models tend to overestimate the Labrador Sea water volume. The bottom panels show the overturning at Osnap West line and at 26.5 rapid line. And some observations from the Osnap West line is shown here. The triangle is the Osnap, the Lozier et al. 2019 estimate. And this is the rapid estimate here. So even though at 26.5 degrees north, we tend to match the observations, we are seeing again, perhaps if this analysis is based on this analysis, we are seeing strong overturning circulation, stronger overturning circulation than the available observation. And when we look at the Labrador Sea water volume and MOC correlations in these models, we see essentially that the Labrador Sea volume water volume actually is leading a positive AMOC anomaly or MOC anomaly in the models. And that's true at Osnap West line, that's the red line here. But if you go further south, that kind of relationship is breaking down and it's not consistent across the models. So one conclusion from this study is that even though in the models perhaps the Labrador Sea is becoming as a showing as a dominant region impacting AMOC variability, perhaps that's due to a much larger Labrador Sea water volume in the models, leading to stronger overturning circulation. And this is also tied to a very recent study, and this paper was published in Science earlier this year, led by Susan. These are showing the first results from the Osnap array, and this is showing a 21-month time series of the overturning transport. And in the interest of time, we can just look at the solid lines here. They are showing the total transport. Full array is given by the black line. Osnap East overturning circulation is given. Osnap East line is given by the blue line, and then the Osnap West line here is given by the yellowish line. So a conclusion from this initial analysis of the Osnap data sets was that at least this 21-month record is not showing any strong variability associated with the Labrador Sea region, and it's essentially indicating that the eastern part is playing a bigger role in the overturning transport and likely in its variability. So this is an emerging new sort of science question. And of course, the record is too short to say anything more conclusively. Another thing that we have done is essentially, this is about to be, I think, accepted in Journal of Climate. I've done quite a bit of simulations. This is showing 11 simulations of 600-year long. And what is shown here is wavelet analysis as a function of these 600-year simulations. from these simulations. And they are essentially showing initial condition perturbations, or in which I modify the ocean model parameter values within reason to check the impacts on AMOC variability. And one, you can see right away that AMOC variability appears to be rather non-stationary. And depending upon which segment of a particular lung you look at, there is quite a bit of decadal to centennial variability among the models, and it's not necessarily robust. And some of the peaks actually shown here are above the significance level for combined sort of when we assess the statistical significance of the spectra coming from all of these models. So the bottom line is that there's substantial variability in AMOC in time, and it is very misleading to conclude based on a 600-year simulation that a dominant variability is this in this particular model, another one it is something else. So if you run the models longer, things can change quite a bit. So with that now, I would like to return to science team activities. As in the past, we continue to have science team webinar series, and this was, I mean, there was very good, this activity was very well received. We expanded, it was initially just for task team 3. Now they are for all task teams, and we changed the time also so that our European collaborators can actually join, listen in, or also they can also present as shown here in the first presentation. We had our last meeting, as I said, in Florida, in Miami, and it was attended by about 103 people. Hello? Roughly 30% of them were early career scientists, and a meeting summary and report is available in EOS. It was published earlier this year. I don't want to go through emerging questions. I mean, some of them are listed here. It includes, for example, the role of the Labrador Sea as well. But we keep track of all of the emerging questions, and some new proposals are trying to address these emerging questions. As I said, the science team will be sunsetting at the end of 2020. So towards this, essentially, we had some discussions in our previous meetings, and we came up with a list of things that we would like to accomplish, partly as legacy products. So they are listed, this is from a handout that we distributed at the Miami meeting. You can see sort of they are gathered around 4 topics: collaborations, priorities, legacy products, and communication, and what we would like to do in each of these. I don't want to go over these in detail. Some of them are ongoing, some will be accomplished starting next year. But one thing that's relevant for US CLIVAR is this one here. We would like to transition the current program to another program, for example, program-to-program collaborators to US and international CLIVAR. From international CLIVAR, likely panel that's closely related to these activities is the Atlantic panel, but it'll be good if the US CLIVAR panels actually discuss among themselves how they can essentially contribute to continuing AMOC-related research and how they want to approach to that. So that would be actually an important discussion perhaps you guys should have at this upcoming summit, because it's a major issue for the US AMOC program. One of the things that we said we would do, we would essentially produce, for example, ocean observation papers. We would also produce a special issue collection, including review and synthesis and science papers related, sort of highlighting the US AMOC activities together with our international partners. So I'm really happy to say that we have now 11 papers. We have an AGU virtual special issue. It is titled as Atlantic Meridional Overturning Circulation, Reviews of Observational and Modeling Advances. 3 of the papers are already in press. In fact, just yesterday, Rangzheng et al. Paper got published. We have, I believe, 7 papers in review. And then we're expecting one more submission looking at AMOC and tracers That should be completed hopefully by Wednesday. But this is actually quite nice that we have essentially a total of 10 to 11 papers highlighting program accomplishments. We have also participated in 2 Ocean Ops papers. The first one is led by Eleanor Williams. It's focusing on the observational part of our activities, observed transport and variability. There are quite a few co-authors here. And the second paper, essentially, it comes actually from International CLIVAR Ocean Model Development Panel, but I included, along with a few other people here, a few paragraphs describing AMOC-related modeling challenges as they exist. So these are actually nice reviews, and that's what we want to accomplish for our sunsetting activities as well. And I would like to just finish with one relatively new project. That's the AMOC Metrics project. And here, it's a funded activity primarily by NOAA, 3 programs, CVP, MAP, and CN, and also DOE RGCM program. Actually, that name changed now, but in any case, it's a collaboration between NCAR, GFDL, and Lawrence Livermore National Lab. We are essentially trying to as the first bullet indicates, comparing model simulations with observations of the natural world we know that it's essential. And we want to make sure that such a comparison actually occurs on a fair apples-to-apples comparison basis. And even though the funding started in September of last year, it took us some time to get people on board to work on it. So we really started in February. So this is just to give you an example of what we are after. This is showing the ocean volume transport from a high resolution and low resolution model version with the parallel ocean program. Those are the red and blue lines here. And if we just naively compare directly available move transport estimate that's given by the black line here. So there's quite a bit of discrepancy, essentially, between what we get from the model and what the move array tells us. And we are essentially, we did the same thing for rapid, and now we moved to move array. We are trying to now compare exactly the same way, computing however the move actually obtains this. We are going to do this, we are doing it the same way. There's still a bit of discrepancy, but in any case, this is the kind of thing that we are trying to address in this project. And we are going to have a mini workshop right before the ocean observations meeting. There are about 15 people participating from various observational groups, and we are going to try to essentially, if possible, come up with a best practice approach that observational people can commonly use, with the big caveat that I know that some groups think that, everybody thinks that their approach is the best approach. And sometimes people need to use a certain approach, but we'll try to see if we can essentially bring a common ground to both the observations and models. And science team, just 2 more things. Science team members have been continuously organizing many AMOC-related sessions at various meetings, AGU Fall, for example, Ocean Sciences meetings, and there are upcoming several sessions in both AGU and Ocean Sciences. And we are going to have our last US AMOC Science Team meeting. And this is going to be likely bringing in other international groups as well. We haven't actually come up with the full concrete date yet, but we are shooting for an East Coast location sometime during spring/summer of 2020. So with that, I'll stop and take any questions that you may have. Sorry, I took more than 10 minutes, I think.
No worries. We'll go over if we have to with questions. Thank you, Gokhan. And if you have any questions, feel free to type in the chat box and I will ask it out loud for you. Or you can always take yourself off mute and ask the question. Or if you need help unmuting yourself, let me know in the chat box and I will unmute you as well. Sorry, we're learning the global mute system still, so bear with us. So do you have any questions? don't see any questions right now.
Gokhan, this is Janet. Can I just ask thank you very much. That was a great presentation. That was an excellent presentation, and I'm just glad to hear that you're being so productive. I have sort of just a question on you showed a slide from the Lee et al. Paper, and
Yes.
And it showed that really strong periodicity, which I guess they're saying is related to the NAO. That's why the index is down there. But we just don't see that in the observations. We see it in all the models.
Yes, I mean, that's another issue. I mean, over here, I guess the implication is that if you look at in the interest of time, I've skipped that thing. The gray shading here shows the NAO index.
Right.
And in some models, essentially, you can see strong correspondence with some positive NAO things of this Labrador Sea volume. And yeah, I mean, but the observations are, again, so this is based on, it's right here, AR7 data, and there's also Argo floats going into observations here as well. And then the older observations, unfortunately, they are, as far as I know, they are not continuous, right? They are just different times.
Oh, okay. So they're discrete transects and everything rather than the common line.
Correct.
Yeah.
Right.
Okay.
So
and
I would say, I'm not saying that necessarily what the models are producing is correct. I'm just saying that I don't think that we have observations to judge whether they're correct or not, one way or another.
Right. No, that's and is it anything? That little mini workshop that you're having, I think that's fantastic, because this is something to develop common techniques for determining these transports. That's really super important, not only for the AMOC, but for lots of us to do transport comparisons.
Right.
Thanks.
I mean, since we had limited funding and all that stuff for this workshop, we were targeting 1 or 2 representatives from each AMOC-related observational sort of groups. And I don't know, while Mike is on it too, but so far we have about 14, 15 people, I think, attending, if NOAA people can get permission. But if there is actually interest attending from other groups too, we can probably make arrangements. But I would leave that thing to Mike, actually.
Yeah, it'll be just good to see what best practices you come out with. So that's great. Thank you very much.
Thank you.
Hi, Gokhan.
Other questions? Go ahead.
Go ahead, Mike. Yeah.
No, you go first.
Okay. Yeah, thanks. That was a great summary, Gokhan. I wanted to follow up on this, both the workshop, but also this large collaborative project. One, do you see this collaborative project being a larger engagement with the community in addition to NCAR, Lawrence Livermore, and JFDL? And two, okay.
Yeah, I mean, I can answer that question initially. So the idea was, we said, let's start with a small group and then bring the observational people together to come up with some sort of synthesis of what's done and how can we essentially make them similar. And the idea is, at NCAR and at GFDL partially, we come up with sort of prototype metrics and the techniques essentially, or the scripts or the diagnostic tools to process these across models in the same way. Then Lawrence Livermore, PCMDI, Peter Gleckler and Paul Durock are involved. That's the DOE-funded part. Their task is essentially to make them as general as possible so that all of these can be used across CMIP 5, CMIP 6 models. And then everything is open. So that's the sort of broader participation aspect of it.
Okay, yeah, that sounds great. And my second part of the question was, can the US CLIVAR panels in any way facilitate the engagement with the larger community, either the POS panel through engagement with the observation community?
Yes, I mean, this is essentially, so can you see my slide? That's the third bullet that I was trying to, so the idea is, even though the US AMOC Science Team will be sunsetting, these activities will continue. And we want to make sure that program-to-program collaborations, and the one that you are actually mentioning is the big one, important one, observations. How do we make sure that they continue into the future in a similar way? So from the international CLIVAR side, I think the Atlantic regional panel is the obvious sort of home. But it is unclear to me, at least, how US CLIVAR can actually help and coordinate observational and modeling activities related to US AMOC program.
Okay.
And that's why I was encouraging the US CLIVAR panels to discuss this at the summit.
Yeah. Yeah, we'll bring this up for discussion, I think, definitely on the POS panel and then across the panels also.
Yeah, I mean, the observation panel probably is a way to go. But then, I don't know, I mean, are you guys actually collaborating? Are there cross-cutting teams across the US CLIVAR panels?
And there are, and I mean, this year, AMOC was not one of the cross-cutting teams.
Right.
It can definitely
because so far it has been a different science team, I guess.
Right.
Yeah. Anyway, I mean, I don't have a solution or any particular suggestion. It will be good to discuss, and maybe we can come back at next year's summit or something and discuss it further.
Yeah. Great. Thanks.
Right. So this is Mike, and I want to just echo the thought that I sent an email out based on conversation with Gokhan last week on this to the co-chairs of each of the panels, suggesting that they at least initiate a discussion of US AMOC activities that map onto their panel interests. So for POS observations and state estimation, for PISMIP process understanding mechanisms and modeling aspects of AMOC, and then for PPAI understanding predictability and impacts of AMOC on other systems. So I think we'll have the opportunity during the business sessions of the panels to take this up, but it should be the start of a dialogue that will extend over the next year through the panel. Next year, Gokhan, we're not having a summit, but the individual panels will be meeting, and perhaps they can have a conversation on this. And then I have been thinking, based on our conversation last week, Gokhan, that perhaps in 2021, even though the US AMOC Science Team has sunset, we'll have the final report, and out and 2021 might be a good time to have a special science session on this topic at our next summit, so that we can really think about how to take forward US AMOC research in a coordinated way after the science team ends.
Yes, yeah, that sounds reasonable.
Okay, any other questions for Gokhan? All right, don't see any more. So I want to thank everyone for joining us today at our pre-summit webinar, and thank you, Gokhan, for presenting. Our next webinar will be this Thursday, August 1st, at the same time, 2 to 2:30 p.m. Eastern Time, and it'll feature our Large Ensembles Working Group co-chairs, Claire Desser and Keith Rogers, which we just held the Large Ensembles Workshop last week, which they'll be covering as well. So thank you, everyone, for joining us today, and thank you, Gokhan, for presenting.